Hi, so we are going to discuss some of the problems that duck typing has, and we're going to summarize what it is. So far we've talked about duck typing and we've been showing its benefits. Now, is there any problem with it? Well, there are a few. So the first thing is that as we see, the idea of duck typing is that it's looking for attributes or methods with a specific name. And as long as that attribute or method has that name there, then it thinks, oh, that's the one that I'm looking for, and I can rely on it and I can use it. Now, it doesn't really care if the objects are can be very different, and actually the attribute or methods with this name that it's looking for can do things that may be incompatible with its expectation. So now, for example, if we have a bird class and an airplane class, and they both define a fly method, now the fly methods are compatible actions. So in that case, duck typing is okay. So we can write something like this, that, well, airplane class has the fly method, bird class has the fly method. They use different ways to fly, but they both mean to, get in the air, right? So we can write a lift off method, and it can take a thing and it can just call that thing dot fly. And if we pass either airplane or bird to the lift off method, then there's no problem there. So this is an example of the methods are doing what the function expect them to do. So this is good where the idea of duck typing works. However, there are cases in which the assumption that attributes with the same name are compatible with each other is false. So, for example, if we have a class boat and it has attribute called bow, B-O-W, and then we have a different class called bow and arrow, and it also has an attribute called bow. Now, both of these has the same spelling in English, but they are entirely different things, right? This is the bow of a boat, and this is the bow of bow and arrow. So they, in most cases, they aren't likely to be used in some compatible ways. So duck typing in this case likely will cause um, big problems. And also, uh, um, uh, we define a vector class before that represents a line with a direction and a length, and it has the attribute x and y, right? Now, we can also imagine that we define a point class that represents a point on a 2D plane, and that point also has an x and a y uh, attribute. Now, uh, our definition of the vector dot dunder add that uses duck typing would allow us to add a vector with a point, right? Because all the dunder add method expects is the other parameter has an x and y attribute. But in terms of the math, it really doesn't make a whole lot of sense to add a vector which is again aligned with the direction and the length with a point. So in this is another case where duck typing does not work. And another problem with duck typing is that it's not always clear what's expected of it. So for example, if we look at our function, print worries and entities, and if you just look at its definition, the first line, you'll be scratching your head and say, huh, what should I pass to entities so that, it would do what I want it to do? Now, so to address that problem, you can, well, either hopefully if the function is well documented, then we would know that, okay, all the items in the list of entities are expected to have the worries method, or you can look inside the code of print worries and figure that out yourself. Now, that is, of course, not desirable. I mean, it's supposed to do things for us without our knowing how it works, right? So that's not desirable. However, if we actually use inheritance, which checks for types, then we can, in the documentation, then we can simply say that the entities are all expected to be a type of person, right? And we can then look at the type of person and see the method that it has defined so that we can actually figure out what's expected of all the entities in this function. And that is especially true if person is an abstract base class, which clearly defines the interface um, that's of the types that are expected to put in this list. So it's not only a problem for human programmers, but it's also a problem for programming tools such as static type analyzers. So it's in fact such a big problem for large Python projects, Python projects that has hundreds, thousands of classes, functions in files. That is one of the reasons that the recent version of Python actually introduced this thing called type hinting, so which allows us to decorate a variable or a parameter or any name in Python with a type. So now it's just a hint. It doesn't make Python a strongly typed language, but it's still quite interesting that after all these years, Python adds type to its names. So anyway, I'm not going to go into the detail of type hinting here. Here is a link to an article that I find have a pretty good explanation. So feel free to take a look at it. So that's all I want to say regarding the problems of duck typing. Now, as a summary of duck typing, so duck typing is all about capability, what an object, what an instance can do, not about the type of that object. Okay, that is in contrast to inheritance, which is all about type, right? And when we talk about capabilities, it's always in the form of the attributes of an object, the data members or the methods that the object has. So if an object or an instance or an argument that is passed to a function has all the right attributes that the function wants, then the function can work. Again, it doesn't matter what the type of that argument is. And duck typing, we saw there are several approaches to how we write code that uses the idea of duck typing. Now, it doesn't really care whether you check before you leap or leap and then try to catch yourself when there's an error. Although, I showed in the previous example, I generally prefer this later approach and just let's do it, but put it in a try catch in case we run into an error. So we continue. Now, if the attributes of of an object or an argument that's passed to a function, they are missing, then there's some sort of error reporting that happens, and usually that takes the form of raising an exception. And finally, kind of between duck typing and inheritance, I'm not taking a position to say, whether one is better than the other. I mean, they are just different approaches, different paradigms or philosophies, whatever you call that. They each have their own advantages as well as disadvantages. But duck typing is used quite often in Python just because of Python's dynamic type system. Duck typing is just a very, very natural part of it. And finally, we circle back to this statement that we quoted at the introduction to duck typing. The statement kind of gives the origin of the name duck typing, and that if it walks like a duck and if it quacks like a duck, then it is a duck. And at the time, I said there's some objection to uh, this to the fact that this statement explains what duck typing is. And now that we study what duck typing is, then we probably can understand some of these objections. So the first thing is, so here it's trying to identify something as a duck. Well, but as we know, duck typing is not quite about identifying the type of something, right? So that's this so it's a duck. Whether do we care if it's a duck or not? Well, not really. We don't care about that in duck typing. And the second objection that I heard is about this statement uh, about walks like a duck. So duck typing doesn't really care about something walks like a duck. It really cares about the capability of this thing, which is if it can walk at all, then we're good to go. So anyway, these are some of the things that I heard, some of the opinions that I heard about this particular statement, and I just thought it was fun to share them.